Good afternoon. Today we are going to solve an uplift question. So essentially, when you want to calculate the uplift capacity, your pipe is in the ground. Um, this is the pipe. And for some reason, due to wind or moment in the structure, you have a force like that. And you don't want the pipe to be pulled out. Um, This happens for tall buildings or um, um, power towers. This is typical, and we need to design for it. So the way to calculate it for a question like this, which is clay, is you get the shear strength, then you get alpha. With alpha, you can calculate the capacity of the skin of the pipe to be for being pulled out. And then you also add the weight because as the pipe gets heavier, you have more pulling out capacity. Um, what you need to remember for your exam is how to come up with alpha. There are tables or charts. There are charts in your reference manual, FHWA, that gives you alpha. This question already gives us alpha, so we don't need to deal with those charts. But in general, that's a good point to focus on when you're studying. The question reads, a 2.5-foot diameter cast-in drilled hole pile is installed in a saturated clay layer to a depth of 30 feet. The soil was found to have an undrained shear strength of 1.5 ksf at the surface and 3.5 ksf at the depth of 30 feet, varying linearly. Given a shaft weight of 25 kips and adhesion factor of 0.5, determine the uplift capacity. So the pipe depth is 30 feet, and also we have the shear strength at 30 feet. So you can easily calculate the SU, the undrained shear strength, by getting the average of these 2 points, 1.5 and 3.5. 1.5 plus 3.5. This gives you 5 divided by 2, 2.5 K S F. The question gives you alpha, so it's easy to get the Fs, which is alpha times 2.5 times S sub U, which is 2.5. You can do this multiplication. I think you can do it in your head. What's the alpha? Alpha is 0.5. It's easy. 0.5 times 2.5, you have 1.25 KSF for the skin friction. So now that we have F sub S, we can calculate Q sub U, the ultimate capacity. So for Q sub U, you can add the weight plus the perimeter of circle is pi times d times L. And then this is the skin surface of the pipe. And then you multiply it by F sub S to get the final answer. So let's just plug this in. 25 plus 3.14 times 2.5 times 30 times 1.25. The answer is 319 kips. So Do we have 320? Yes. We have option C. So this question was uh, a little more difficult because it is from something that is not from the manual, and you need to know how the uplift capacity in the alpha method can be calculated. But once you know that you need to get the average shear strength multiplied by alpha and then add the weight, then the rest is relatively easy to solve. I wish you good luck for next week of studying. And if you have any question that you want us to solve during the next week power hour, let us know. Thank you.